Yeah, efficiency over on your head. Oh, wow. No, I did not see that coming. You can't tell. That's what he's talking about. Yeah. I look like a burger.
The burger.
Hamburger.
The second one's my favorite. I love that movie. Why have I not watched that movie? That movie is so funny. Oh my gosh. When he's sitting in New York and he takes a bite of the cheeseburger and it's like panning around him and he's just it's so funny.
And he does like that lady.
It's so funny. Beyonce is in it and she is so hot. He's like in like the French like head of police's like office or whatever. And he's like to be one of us. Sneak attack! And he like slams the curtains and it like falls over and he's like you know what it's the I love it.
I just like to grab it. It's so funny.
In the
Where he goes into the office, the lady's like, politically correct.
I don't even know what he says.
I was driving my Lizzie. I did the other way. Big family to you.
Really?
And I would drive my Lizzie yellow.
Is that the new Flash golf?
Yeah.
It's so hard.
Is it harder?
Hey, quiet now. How you doing?
Whoa.
Hey, listen. Couple things for the test. One, whenever you encounter something that's, like, for example, e to the negative x, if you write in e to the negative 1x, you'll find yourself making fewer mistakes. So I did that. Next thing, this negative here in the quotient rule, if we take care of that at the very end, I've noticed that people make fewer mistakes as well. So I haven't done anything with that yet. So I have a question to hear.
Wait.
Please.
Can you just explain to just the E rule, I think is what you use, right?
So here, this, help me out. Oh, what's this equal to?
0.
And then this times this would be?
0.
Good. Then here I use the E rule. So the derivative of e to the something is e to same something, derivative of
Oh,
something.
that's okay. Thank you.
Good. I forgot the dx, don't do that, sorry. Just do the whole class, I'll pay everyone. Who knows what this is without saying anything, just look at it. What's this, just raise your hand please, what's this gonna be? Okay, everybody who tries. Let's go Willy Wonka. -1. Willie says -1, who agrees? 2 for all, 3 for Mr. Wonka. Sweet. Look up here. Take care of the negative last, really. So I've got 1, 2, 3 things that need to be multiplied. You may multiply in any order. So -1 times -1 is +1. That would make this negative e to the negative x. But then times negative again switches back to, I messed up big time. So listen to me. Negative times negative is positive, then times the negative is negative. Sorry about that.
Wait, so like you can multiply the minus sign out kind of?
You're just all right here.
There's no distribution if that's what you're thinking.
Well,
Go ahead, keep talking, keep talking.
I'm just confused because I thought that's not factored since it has the minus, it's 0 minus the -1.
The 0 doesn't do anything, so I can just forget that. So all I really have left in the numerator is -1 multiplied by -1 multiplied by e to the negative x multiplied by -1. So the 4 things that need to be multiplied, you just pick 2 and start. There's no distribution because nothing's being added. So I just chose, I always do this one last. So multiply these 2 to give me +1, times this would be positive e to the negative x, times this would be back to -1 e to the negative x. I'm going to sure that makes sense for you.
I got it, yeah.
Chad?
If the 0 was a different number, could you still do that?
Good comment.
Like if it was like a 2 or something like that?
Yeah, it really wouldn't matter what's here. 3 points, really good question. Chad, it wouldn't matter what's here, whether it's x squared or just anything.
Yeah.
I would still handle all of this the same. I would
So-
still.
So like, let's say, so you multiply it and it's -1 e to the -1 x. If it was like a 2, would you multiply the -1 by the 2 at that point?
No, because that's still two things separated by subtraction.
Okay.
So there would be like a 2 minus.
Okay.
Is that what you meant? Good question. So really, it's a group of terms being multiplied minus another group of terms being multiplied, and they don't multiply together. Anyone else? So now I'm here. This is factored, so these divide. So one of those on the top divides with one on the bottom. Last step. One more, I guess. Questions? Please, Brady.
Why did, on the second last step, why did you just do -1/1?
Right here.
Did you just like separate the two?
What I did is, I've seen a lot of people make mistakes with this situation. I've seen them do, more common would be something like this. Let's go on a second. So the mistake I've seen before, Braden, looks like so. I've seen people say that this is the same as this. And that's not true. The only thing that has an exponent is the e, so the only one that can move to the numerator is the e.
Okay.
So I wrote it as two separate fractions, just to make sure no one thinks I'm doing anything with this. I'm not. I'm just working on this piece. Does that make sense?
Yeah. Cool.
Any other questions on this one?
Can you like scroll up just a little bit?
Yes. 1 second.
Change it. You are.
No.
Never sure.
You have about one more step.
Yep.
That is half down.
You're good. This way, right?
Sorry.
So like, that is the x go, oh, multiplied out, so it creates 0, right? So the first you did the negative x, the other number comes 0,
And
so
then you put the
multiplies
negative on the
by-
bottom of the top. You probably put it back on the top.
0 minus
The property is this one here. 1 over
Same.
any expression, any, to a negative exponent is equivalent to the same expression to a positive exponent. You can do it the other way. So you can say anything to a negative exponent like this is equivalent to the. Now, whether they actually write it as a negative exponent in the numerator or a positive exponent in the denominator, there's no really specific rule for that. They'll do it both ways. You just have to go back and forth. Chad, you good?
Yeah, I'm good.
Anyone else question on this one? You know, a different one you'd like to look at? Please.
You're looking for the
13?
Yeah.
So the costume would be complete if you had the motor home in the parking lots. Read it to me, Chris. 13, you said.
Yeah. So y equals 2 e to the x plus 2x to the e.
Don't you
No,
say?
2x to the e.
Oh, sorry. We can use the add subtract property right away. We use the constant property, so the 2 just comes along. The derivative of e to the x is e to the something multiplied by derivative of that something. Pull out the constant. Here's where they try to fool you. E is just a number. It's approximately 2.7.
Oh, that's.
So finding this derivative is really no different than finding the derivative of, say, x squared. Just bring down the power, multiply by the base, subtract 1 from the power, derivative of the base.
Oh, okay.
Just the power rule.
That's right, yeah.
Wait, how are you gonna get?
Yeah, they wrote the problem in a way to just try and get you uncomfortable. So, that makes sense.
So you did the power rule instead of the.
It has to be the power rule.
Okay.
Because, see, what causes trouble is, you just forget that E is just a number.
Yeah.
2.7, just x to the 2.7. Question mark. Wait. You guys already? 15. Do you else have anything here? Come on, eh? Read 15.
I said.
Exactly.
Big shoulders.
Don't forget parentheses. I was helping someone this morning. They had done everything right, but they forgot to put in parentheses and they made the mistake. And don't say to yourself, oh, I don't need parentheses because I know what it means. In the pressure of a test, you forget what it means. And you just start reading what you've written and you get it wrong. So make sure you use parentheses. Question? I'll just check the whole room. I'll give away some tickets. Raise your hand if you know what this is, please. Show me your hand. Just look at it and identify the derivative.
Wait.
Without writing anything. This one right here. Show me your hands. Who knows? Show me your hands. Let's go Oakley.
Just 2x.
Oakley says 2x. Who agrees? 2 and 3 for Oakley. Do this one, please, as well. Go. Show me. You know. Show me what this one is. Mikkel? Mikkel says 4x. Who agrees? 2, 3 for Mikkel. Okay, factoring. fail the factor, you will fail. It happens so often, we just have to keep practicing it. So it's someone to help me. At this point, you should look to factor if you can. So someone raise your hand and tell me, what are the factors of the numerator right? Well, we really don't have the numerator factor. We do have an expression, it's what Chad asked about. We have an expression here, minus another expression, we'll worry about the minus at the end. Therefore, we can try and factor something from this and from this. So someone tell me, what are the factors of the first expression? Deborah?
6x squared, 6x.
Oh, you're multiplying it out, my bad, sorry, I missed, no worries. I don't want to, you can multiply that, it's perfectly fine. I just want to get us a little more practice with factoring. So I want to just look at this and say, without multiplying, what here is being multiplied to create this expression? So Lexi.
3 plus 2x squared.
That's perfect. 2 for Lexi, 2 for Deborah. Lexi, what is being multiplied here? What are the factors?
1 plus x squared and 2x.
Someone else, what factors are common here and here? Go ahead.
A 2 and an x.
Perfect. So I write dy over dx, 2 for Landon. And take out the 2 and the x. Someone tell me what's left of this expression, please.
3 plus 2x squared. No.
2 for Chad. Someone tell me what's left of the other expression. Braden.
1 plus x squared times 3h.
Nicely done. Just do not forget the parentheses. 2 for Braden. That type of factoring that I just did will show up in some future problems. So once you get used to it. Chad, please.
Just like, I'm pretty sure about this, so you can't take out the 3 plus 2x squared thing until you've completed back to the top, right?
Correct. You're looking at this one divided by this one, right? Yeah, these don't divide because the numerator is not yet factored. Now the numerator is in factored form, but it still doesn't work.
Yeah.
Because the factors of the numerator are now 2,
And then all of
x,
it.
and all of it.
Okay.
Good call. Does that make sense?
Good.
Anyone else? Sweet. So we keep going. So dy over dx. It's actually easier to go the way Deborah was going, just to multiply out and combine like terms. I just wanted to get a little experience with factoring, so. These parentheses aren't needed. We multiply the 2 first, we'll worry about the negative last. Question? So now the negative distributes. This 2x and this 2x squared, they add to make 0. The 3 and the negative 2 add to make 1 times 2x, we're done.
Boom. Oh, it's a constant on both sides.
Question?
Wait, so is the 3 the constant?
Please.
Can you do how you just got 2x at the top?
Huh? So, are you feeling okay here? So what I noticed is I now have 1, 2, 3, 4 terms being added. I can add in any order. So positive 2x squared added to negative 2x squared would make 0. 3 added to negative 2 would make 1. 1 plus 0 is 1. 1 times 2x is 2. Does that help? Good.
Can we do number 16?
Let's have a question here. 16? Read to me.
X squared y. Minus 2y. Plus 5. My view now, the problem is figure it out. No, who says that? Because I'm just smiling as I'm sitting. That's his right. That's right. He knows what's up. Nice.
Questions from anyone? Anybody question? This is 2x. Move this to the right side. Question, letting step. Good. My handwriting's getting really bad. Lindsay forgot her glasses. Can you sit closer? Okay, just making sure. I'm just making sure. So like, so you see, like squinting at You have a question? You're up, hopefully. Do your thing.
All right. Oh, wait.
Wait, she does have like a leaf off.
Take it out, go.
20 plus 5.
Jump off.
Yeah.
Jump.
I can touch the
You're not
rim.
even good.
I can touch the rim.
I throw it down on the 7 foot.
You do.
Okay, everyone look at the board. Everyone
Truth
look
on the
up.
speaker on the rim.
Brady, look up. Brady, look up.
Yeah, Brady.
Look up, look up, look up. Hey. Like really look at the board. Okay, this problem is one that really it's not hard at all, but it has fooled people a lot in past years. So really pay close attention to the steps, make sure you don't miss any. Okay, here we go. One of the best costumes I've seen over the years. One year there was a group of 4 young men. They dressed up as a mariachi band, but they all could play the instruments. It's like one guy had a trumpet, one guy had a guitar, and like they were seriously playing the music as they were walking around the hall. Yeah. Another really good one was Chandler Shomik's brother, Kenny Shomik. He had a friend who was just really small, like a really small, only about this tall. He kind of born with some health problems. A really smart kid, Taylor Nielsen. So he dressed up like Max from Where the Wild Things Are, and the pajama thing, right? And his friends were all big guys, so they all had big, huge, these gigantic Wild Thing costumes.
That's slightly cool.
Slightly cool.
Awesome. That's just a I'm sorry, I just contradicting Brady today. He's just being the cube.
I know.
You're
So
cute.
it's cute.
Derek, have you seen the video of the dog?
Yeah.
That is the cutest thing I've ever seen. It's like the dog's like favorite toy or something. He dresses
No,
as a
I-
huge one and the dog just like slowly stands up and he just gets so happy.
It's the best video.
It's so cute.
What is it?
It's like this, so this dog, there's a chew toy for this
Dog,
dog,
yeah.
and he's like just chewing on the toy, and then his owner walks in what Derek's wearing,
Gummy costume?
and the dog kind of just like freezes and just like,
And he
and
just like walks
slowly
over
just
to
like
it.
gets up and like walks over, and then just starts going.
He's, like,
nuts.
so happy.
It's the happiest dog I've ever seen. It's so cute.
Yeah.
That's funny. Where'd you find this video?
Please have.
So what?
No one talk to, no one talk. So I take the derivative of both sides. I use the add subtract rule first. Then here I use the constant rule as all. Here I use the product.
So how do you know like what is constant?
Either way, fine.
Got it. Okay, no one talk, no one talk. We have to break them. If you have two things being multiplied together, and one of the two is a constant, for example, e, pi, 5, -1, then you just use the constant rule. If two things are being multiplied together, and both of them are functions of x or functions of t, whatever, they're functions, they're variable expressions, you have to use the product rule. Now, one good thing, Hannah, if you forget and use the product, Chad mentioned this just a minute ago, if you forget and use the product rule on something like this, it's fine, it will still work. It's not wrong, it's just a little quicker to use the constant rule.
Yeah, I learned that the hard way.
Everybody good? So now we have dy dx. E is a constant because E is approximately 2.7. So it's a value that isn't changing with x or with time. The derivative of the x is just e to the x, derivative of the x. That's 1. This one becomes the same. I don't think anyone's going to miss one like this on the test this year because we've been emphasizing heavily a very key concept with regard to factoring. So I need someone to tell me what can be factored from these three expressions. Two for Jeff. So Jeff, if we factor e to the x from this expression, what remains?
5.
Last, what remains from this expression? That's the problem.
And then that's.
Yeah, it was the forgetting that a factor of 1 always remains is where people make mistakes.
If it was multiplication though, you could just leave it, but since it's addition, you have to have the 1.
I gotta write this down, because you have a really good question, just not picturing it. Say again.
So like, if it was like 5e to the x multiplied by e to the x multiplied by x e to the x, you could like divide e to the x, right?
Then only one of them would divide.
Oh, you're right. Okay.
Your question's a really good one. It just doesn't quite match up. No, it's a good question. The idea is, of course, like I say, every one of these expressions has a factor of 1. We just don't write the 1. So here we have to make sure we write the 1. That was probably your mistake, right?
Yeah.
That's
Because
most common.
when I would try to solve like the answer, I just got like 6ex plus x dx. Didn't understand, but they just came out like.
Like silly.
Yeah, you have to know both the norms. You have to know both. You can't predict what the AP people will give as a multiple choice answer. You have to know both. Yeah. So we have a different question from the practice test. Please. Read to me, guys.
Y equals the inverse sine
all I know is apparently children have way too many holidays. So like, we were, I have a granddaughter, she's like 3.5. And they were kind of asking her, what's tomorrow, Lily? And she's like, first Halloween, then Disneyland. Because we're going to Disneyland for Thanksgiving. She's like, oh, nice. Well, look forward to it. So she's like, first Halloween, then Disneyland. So then they said, no, okay, good job, Lily. She's like, so what's tomorrow? Christmas. She's a little mixed up. She was very sincere. She was like, Christmas.
Just getting mission stuff. What do you think for Christmas? What do you do for Christmas?
Here's the most common mistake. Here's the most common error. Braden.
My bad.
That's all right.
I debated that, but.
Elijah, look up. Elijah. Yes. Good job.
Oh.
Sweet. Yes. 2 tickets for Jared. Okay. Quiet. Most common error is this. Remember, do the negative last. Okay, to square something means to multiply by itself. If you'll always use that saying, to square something means to multiply by itself, you'll not make a mistake. And then the negative, we take care of that last. The derivative of 7x is just 7. This multiplies to become 49x squared, then you take care of the negative. Question? What? Is that a different question? Anything else from the practice test? Please, can we go over to which one? 22. Yep, we're going to do that. Here's the new practice test.
How many practices?
Hey. Look, on Wednesday, everybody look at the test. Braden, look up at this. Look at me. This is the practice test for tonight. Okay, this one has 35, just gave you a few extra to practice for the last time before the test. We don't have time on Wednesday to be grading this at all, so this one I just give you the answer. See?
Yes. No, it helps me so much because if I don't know if I'm doing it right or not, that like
It kind of hurts inside. It makes
It's kind of a mix. You have to learn to kind of have that feeling of doing a test without having any answer.
Yeah, I agree with that.
You understand? It's a mix. I get it. I feel just like you do. I'm like, I kind of want to get that feeling of taking the test, but I also want to know if I'm doing it right.
Yeah.
I miss that. I was just big
Just keep saying
I was talking to somebody, I think it was Peggy. Yeah, who's on your team, the J-Guys? We'll use the Chad, Goose,
Yeah, dude, like if you call it being technical, keep on.
I still remember our first game, picks up their biggest player.
challenge.
Yeah, go fast, take Philip first. Yeah, I am actually not
Oh, Chad, let him take it.
Should I love speak one better, or am I still you just want in your class? That's right.
Chad, you're not gonna use it.
Yeah, I am.
Anytime.
I am. Should I wear my long sleeve?
When are JJ's? Pretty soon.
They're. Should I wear my BYU one or my long sleeve?
They've got to be soon. When are they?
Which one doesn't hurt your head?
You can sign it now.
I just want to go through the hallways, like trying to cross over everyone.
Watch out.
That'd be awesome.
I know it's Dobby, but it's
Hey, your
scary.
class is sick.
Kind of like me. Ball's coming with me.
No, it's not.
Chad! Oh!
Brady, your highest computer, top dribbling.
Yeah, I'll know.
Yeah, give me my ball. That's my ball. I deserve it.
Oh, he's got shoes and everything. My little brother's 20 years ago. Very nice. Yeah. See you guys.
Did you have to cut the sides?
Yeah.
Thank you, Mrs. Smith.
And
Have a big day.
you too.
And the back?
Good fit.
Oh.
And Adam